So we're going to move on to the last piece of this review unit, which is encompassing the unit circle and everybody's favorite trig functions. Now, I cannot stress enough how important this unit circle is, and I'm going to go over kind of some shortcuts to help you remember what the values are on the unit circle and how we can kind of use some patterns to help us remember this. And I'll also go over some more, I don't want to say more important points on the unit circle, but there are definitely some points that show up more often when we're working with our calculus problems than others. So to begin, hopefully we remember that on the unit circle, this right-handed point is our beginning point, okay, our standard position, and its coordinate would be 1, 0. Just like a graph or an XY plane, you would go right 1 unit, but then you don't go up or down at all. We could probably fill out the other easy points on the unit circle, meaning the top, left, and bottom points in the same kind of manner. The top point would be 0, -1, leftmost would be -1, 0, and at the bottom we have 0, 1. So I would say those are 4 very, very important points to know. There are also the ordered pairs in the first quadrant that are extremely important. But the other points in the other quadrants sometimes show up, which is probably not as often. So just as a general rule of thumb, I would say the first quadrant ordered pairs and top, bottom, left, right are the ones that we definitely have to know. So in terms of a shortcut, hopefully we can recall that many of these ordered pairs on the unit circle deal with fractions and square roots. And typically students get kind of uncomfortable when it comes to those types of numbers or values. So to kind of ease you through this, I just want you to remember to count 1, 2, 3. And hopefully by now in your mathematical career, we are able to do that. So if you take a look at this first ordered pair that we wrote here, I want you to find the 0 value, which in this case is in the y coordinate. And if you want to fill out the points in the first quadrant, I want you to count 1, 2, 3. So again, we're starting with the 0 coordinate, and then we're going to count 1, 2, 3. Doing the same thing, this topmost point, the 0 is in the x spot or x coordinate, so we're going to count 1, 2, 3 in order to fill out the rest of them. Now maybe let me write those down a little bit further. We'll let these lines represent the fraction bar for these values. Alright, so far our shortcut is just counting 1, 2, 3. Next, these fractions are conveniently all having a denominator of 2. And I want you to take the square root of all of the numerators, okay, all of those top values. Now, you could take the square root of 1, but that's just going to be 1 anyway. So really, only the numerators of 2 and 3 are going to have those square roots. So there are the ordered pairs in the first quadrant. We can fill out the remaining quadrants in the same fashion. So find your 0 and count 1, 2, 3. Find your 0 and count 1, 2, 3. They're all over 2. And square root of the tops. Let's go ahead and try another quadrant. So find your 0, count 1, 2, 3. Find your 0, 1, 2, 3. All over 2. Square root of the tops. Now this shortcut I'm letting you kind of hint on is by no means a mathematical shortcut. Okay, hopefully you spent some time in your pre-calculus class discussing why these coordinates are the way they are. This is just a simple shortcut to help you develop the unit circle. That way you can use it to help you solve some problems. So our last quadrant, find your 0, 1, 2, 3. Find your 0, 1, 2, 3. All over 2. And then square root of the tops. So very simple, easy shortcut to help you fill out those numbered values. Since we are dealing with a coordinate system, we have to make sure that we have the correct positive and negative coordinates. So in our first quadrant, all the x values and y values are positive. However, in the second quadrant, we know x values are negative, y values are positive. So we have to show that in our ordered pairs. So in front of all those x coordinates that you wrote in, we're going to have to throw in a negative sign. In the third quadrant, x's and y's are negative. So go ahead and throw in negatives for both values. And then in the fourth quadrant, only the y's are negative. Alright, so those are all of the ordered pairs. Let's go ahead and talk about the radian values. Last year you should have discussed two different types of values that you can write on the unit circle. Those are either degrees or radians. I know your brain is mostly geared toward degrees because that's what you learned first way back in elementary or middle school. But this year we are totally going to be focusing on radians, which are those values with the pi's in them. So it may be a struggle at first, but we're going to power through and get used to them. We're just going to take our time to get used to and accustomed to using these radian values. So if this right hand point over here is our beginning angle, that has a radian value of 0. And if you were to do a semicircle, we know that is 180 degrees, but the equivalent radian is pi. So if a total semicircle is pi, then if you went half of a semicircle at the very top, that would be half of pi, meaning pi over 2. And if you went 1, 2, 3 pi over 2 sections, you would have 3 pi over 2. And if you happen to do a full circle, that would lead you to 2 pi. Notice how the fractions is just counting by a half. We start with 0, and then we have 1/2, and then 1, and then 1.5, and then 2. So to fill out the other ones, this initial 30-degree angle has an equivalent radian of pi over 6. Hopefully you are familiar with that conversion factor. Maybe we'll go ahead and write that down. Okay, 180 degrees equals pi radians, or maybe rad for short. So you can go ahead and use that conversion to help you move between radians and degree values. So if 30 degrees is 1 pi over 6, then 60 degrees all the way up here would be 2 pi over 6, but that can simplify to pi over 3. And then we have 3 pi over 6, but notice how that simplifies to the 1/2 that we already had. Next we would have 4 pi over 6, but that can simplify to 2 pi over 3. Next is 5 pi over 6, and then 6 pi over 6 would just simplify to 1. We can keep going. We'd have 7 pi over 6, and then 8 pi over 6, which would be 4 pi over 3 after you simplify it. Next would be 9 pi over 6, but that's the same as the 3 over 2 that we already have. Then we would have 10 pi over 6, but that can simplify to 5 over 3. Then 11 pi over 6, and lastly 12 pi over 6 if you were to do a full circle, but notice how that simplifies to 2 pi that we already had. So again, we're just counting. I know it's some fraction work in counting, but it's not that bad if you just keep track of the last value that you had written down. We still have some other ones to fill out though. This middle point is the 45-degree angle, but if you were to convert from degrees to radians, you would get pi over 4. If we were to go another 90 or another 45 degrees, would be at the very top, aka 90 degrees. So this would be 2 pi over 4, but notice how that simplifies to 1 over 2. If we move another 45 degrees, we would have 3 pi over 4. Next, we would have 4 pi over 4, but that's the same as pi. Another round would be 5 pi over 4. Another round would be 6 pi over 4, but that's the same as 3 pi over 2. Another round would be 7 pi over 4, and our last round would be 8 pi over 4, which is the same as 2 pi. So there we have our completed unit circle. This is going to be a very good reference page for you to use as you go through some of the problems that we're going to have this year. So definitely keep this handy. All right, so last thing we're going to do is we're going to discuss what exactly is positive and negative within these quadrants in terms of some trig values like sine, cosine, and tangent. So using these ordered pairs, typically the x-coordinate is representing cosine, the y-coordinate represents sine, and tangent, which is our third commonly used trig function, happens to be y over x, aka sine over cosine. So we're going to use that relationship to help us figure out what's positive and negative. So in our first quadrant, notice how we had positive x values, so that must mean cosine is positive. We also had positive y values, so sine must also be positive, and if you were to take a positive y divided by a positive x, you would get a positive value, so therefore our tangent number or value should be positive as well. So it looks like we don't have any negative values for these trig functions found in the first quadrant. In the second quadrant, we labeled negative x's, so our cosine value should be negative. The y's were positive, so sine should be positive. And if we were to take a positive y divided by a negative x, that would result in a negative value, so tangent should be negative in the second quadrant. Moving on to our third quadrant, we had negative x's and negative y's, so cosine and sine are both negative. If you were to take a negative y value divided by a negative x value, that would result in a positive number, so tangent should be positive in the third quadrant. And last but not least, our fourth quadrant, we had positive x's, negative y's, and if you were to divide a negative y by a positive x, you'd get a negative value, so tangent must be negative in the fourth quadrant. I'm hoping this is a good jog of memory from your trig studies last year, so like I said before, this is going to be a very useful and handy go-to unit circle for your problems and notes this year.